Sequence is classified into the four types. The arithmetic sequence, where the numbers are increasing or decreasing by a common difference. For example, here there is the difference between first and second term, that is +4. So that is a common difference, which is repeating between all values. We're going to use this formula to find nth term value, for example, an+b. So if we find the nth term value, so we can figure out any value in this sequence. In quadratic sequence, when we find the first difference, that's not a common. We have to proceed to the second common difference. So we're going to use this formula to figure out any value in quadratic sequence. While a geometric sequence, we can find there is a common ratio between a different number. So there's a one common number if you multiply any term, so you're producing the next term. So A1 is the first term value, while R is a common ratio between these different numbers raised to power n is the term number minus 1. We're going to use this formula to find any value in geometric sequence. While a cubic sequence is comparatively more complex. Why? Because we find the first difference, that's not a common. We proceed to the second difference, that's also not a common. And the third difference is a common. So we're going to use this formula, n cubed plus bn squared plus cn plus d, so to figure out its nth term value. We're going to see the first arithmetic sequence. In this arithmetic sequence, so first we'll find the common difference. For example, this is the common difference. Second, we need to find the value of a and b, in which a is equal to the first difference. What about a plus b is equal to first term value? So here we have equation a plus b is equal to 6. If you're going to substitute this value here, so of a, so we can find 4 plus b is equal to 6. Here, 4 is plus on one side, other side that will subtract it, and this will produce plus 2. So here we're going to substitute the value of a is equal to plus 4 and b is equal to 2 in the given the nth term formula. So we got 4n plus 2. We can check this nth term formula by substituting the value of term 1. For example, the n is equal to 1, so this will produce 6. That's the term 1 value. And in the same way, n is equal to 2, that is producing 10, so this is second value. And in the same way, the 3 will produce 14, and then if we substitute 4, it is producing 18. If I substitute 5, so 5 multiply 4, that is 20, plus 2, this is 22, and this is my fifth term value. So we can find any term value by using nth term formula. We're going to see there's another number here, and where there's a decreasing sequence from 22 to 15 and 8 and 1. So here is a minus 7 is a common difference between them. You can find by using the calculator the 15 minus 22, that will produce minus 7. In the same way, the 8 minus the 15, that is producing minus 7. That's a common difference. So a is equal to minus 7, and a plus b is equal to 22. We're going to substitute the value of a here in this equation. So this will produce minus 7 plus b is equal to 22. Minus 7 is the one side is minus, other side that will be substituted, that will add it. And this will produce 22 plus 7, that is 29. So we got the value of a and b. So we're going to put this value in a given formula. So we will get minus 7 and plus 29. We'll rearrange this formula. The first figure should be a positive, so that's why 29 minus 7n. So here we can find the any value of, for example, if I substitute value of n is equal to the 1 here, so we'll get the first term value, 22. If I substitute the n is equal to 2 here, that is a second term value, 15. And in the same way, the 3 will produce the third term value, 4 will produce the fourth term value, and if I substitute the fifth, so this is minus 7 multiplied 5, that is minus 35, plus 29, this is going to produce minus 6, this is my fifth term value. So you can find any term value by using this nth term formula. We are proceeding to another number of arithmetic sequence, which is comparatively more complex. These are the mixed fraction. In this mixed fraction, a 5 whole 1/2 and 7 and 8 whole 1/2 and 10. So you can directly find the difference by using the calculator, or you can first convert these number mixed fraction into a decimal number. For example, 2 multiplied 5, that is the 10 plus 1, 11 divided by 2. This will produce 5.5. In the same way, we can convert 2 multiplied 8. This is 16 plus 1, that is 17 divided by 2. This will produce 8.5 value. So here, the first difference is our common difference, 1.5, between these different numbers. So A is equal to first difference, A plus B is equal to first term value. We're going to substitute the value of A here in this equation. So we'll find 1.5 plus B is equal to the value, that is 5.5. So 1.5 is subtracted on one side, that 1.5 is plus on one side, that will be subtracted to another side, and that will produce plus 4. So here we have a value of A is equal to 1.5, while the B is equal to plus 4. We're going to substitute this value in a given formula, an plus b, so we can find that's 1.5n plus 4. So here we can see that the value of n is equal to the 1, mean the first term value, that is 1.5 multiplied 1 plus 4 is equal to 5.5. So in the same way, we can find n is equal to 2. This is second term value. N is equal to 3. If we substitute, that is the third term value. That is 8.5. And fourth term value. And in the same way, the fifth term value, the 1.5 multiplied 5 plus 4, that is equal to 11.5. That is a fifth term value. The examiner can also ask the type of a question. For example, here, the which of the sequence is equal to the 71.5 value. So if that the value of the term is a given, and we need to find about the number of the n. So if you want to find the number of n, we will substitute the same value in the given nth term formula. 1.5 into x plus 4 is equal to 71.5. Here, the 4 is the plus. We're going to substitute 4 at the both side, and that will produce 1.5x plus 4 minus 4. So that will cut in the one side. Another side, 71.5 minus 4. So that will produce 1.5x is equal to 67.5. Here, 1.5 is multiplying. Other side, it's going to divide, and that will produce the value 45. So this is 45th term is equal to 71.5. So we have done the arithmetic sequence. We are proceeding to the quadratic sequence. In a quadratic sequence, the number, they have the difference first and second difference. We need to proceed. So the difference between 1, 4, 9, 16. So we need to find the first difference, which is not a common. So for example, the difference between 1 and 4, this is plus 3, 4 and 9, plus 5, and 9 and 16 is a plus 7. So to find a common difference, we need to proceed to the second difference. And we can find the second difference as a common difference between these numbers. So the second step, we need to figure out the value of A, B, and C in the given formula. Now A is equal to plus 2. So this is going to be 2a is equal to plus 2. And here, 3a plus b is equal to the first difference, while a plus b plus c is equal to first term value. So here, for example, like in a given formula, so 2a is equal to the second difference, 3a plus b is equal to first difference, and a plus b plus c is equal to first term value. So the first we will find out the value of a here. For example, the 2a is equal to the second difference. This is 2. 2 is multiplying, and other side it will divide, and the value of a is equal to 1. In the same way, that is 3a plus b is equal to plus 3. So here we know the value of a. We're going to substitute the value of a here in this equation. So that will produce 3 multiply 1 plus b is equal to 3. So here 3 is a plus, other side that will substitute. So we'll get 3 minus 3. That will produce the value b is equal to 0. So here we're going to find the value of c by a plus b plus c is equal to 1. Right now, we have the value of a and b. We're going to substitute this value here, and that will produce 1 plus c is equal to the 1. If there's a 1 as plus, other side that will substitute, and we got the value c is equal to 0. Here, these old value of a, b, and c, we're going to substitute in the given formula n square plus bn plus c. So here we can find, so that any value which is multiplying with 0, that will become 0. So that's why this is n and c, it will be removed, and that will produce our final formula is n squared. We are not supposed to write the 1 here because it's already understood. The coefficient is 1. So the final formula will become n squared. Now we're going to check this formula, the n squared. For example, if I substitute the value of the term 1, so that term 1 is n is equal to the 1. If I substitute 1, so 1 raised to power 2, that answer is 1. So in the same way, the 2 square is equal to, that is a 4, that's the second term. In the same way, n is equal to 3, this is producing third term, and n is equal to the 4 and fifth, that will produce the further given terms. So in this way, if you have this formula, you can figure out any value in the given sequence. We're going to see the second example of a quadratic sequence. So in this example, you can see the number are changing with the difference. For example, the difference between 16 and 9, that is plus 7. And in the same way, plus 9 and plus 11. So that's not a common difference. We're going to proceed to the second difference. That's a common difference. And then we're going to find that 2a is equal to the second difference, and 3a plus b is equal to first difference, and a plus b plus c is equal to first term value. So here we are going to find the value of a. 2a is equal to 2, and we'll get the value of a is equal to 1. What about 3a plus b is equal to 7? So here we have the value of a. So we're going to substitute this value in this equation. So we'll get this value 3 multiply 1 plus b is equal to 7. So the 3 plus and other side that will substitute, that is subtracted, and 7 minus 3 is plus 4. And in this way, we're going to find a plus b plus c is equal to 9. We have a value of a and b. We're going to put this value in this equations. So you'll find the 4 plus 1, that is 5. This 5 will be subtracted to another side, and that's going to produce 9 minus 5, that is plus 4. So here we have value of a, b, and c. We're going to substitute this value in the given formula, that is 1n squared plus 4n plus 4. Here, this formula will refine in a final stage, that is n raised to power 2 plus 4n plus 4. We can find any term value by using this formula. For example, if I'm substituting the value of n is equal to the 1 first term, so that is producing 1 squared plus 4 multiply 1 is plus 4. So that is producing 1 plus 4 is equal to 9. So that's my first term value. In the same way, if I'm going to substitute the value of n is equal to the 4 here, so 4 raised to power 2 plus 4 multiplied 4 plus 4 according to this formula. So we're going to find 4 raised to power 2. This is 4 squared is equal to 16 plus the 4 multiplied 4. 16 plus 4, that's the 36. So here This is my fourth term value here. You can also figure out, for example, if you're going to substitute the value of n is equal to the 5, fifth term value. And that is producing 25 plus 20 plus 4 is equal to 49. So you can see 49 is my fifth term value. So we're going to see that another number in a quadratic sequence, for example, you can see the first difference of this complicated number, and then the second difference is a common difference. So we found the 2a is equal to second difference, and 3a plus b is equal to first difference, and a plus b plus c is equal to first term value. We're going to find the value of a, for example, 2a is equal to the 6, and that will produce a is equal to plus 3. And what about 3a plus b is equal to 15? We're going to substitute the value of a here. That is the 3 multiplied 3. That's going to be 9. And this 9 is plus, other side minus, and that will produce b is equal to plus 6. In the same way, a plus b plus c is equal to 4. If you're going to substitute this value and subtract to another side, that will produce c is equal to minus 5. Here, we got this value, and we're going to substitute this value in the given formula, an square plus bn plus c. So that is producing 3n square plus cn, 6n minus 5. So that will be in a further refined state, that is 3n squared plus 6n minus 5. That's the same formula. So we're going to put the value of n here in this formula. So we'll find n is equal to the 1. If I substitute the value of 1 here in this formula, so you can see, so first we'll find the 1 squared is 1. So that is 3 multiplied 1 is 3, and 6 plus 6 and minus 5. And the 3 plus 6, that is going to be 9 minus 5, that is 4. This is my first term value. In the same way, if I'm going to substitute this value of n2, so I'll get second term value. And if I'm going to substitute this value of 4, so in this way, 4 square is 16, and 16 multiplied 3, that is producing 48, and 6 multiplied 4, that's producing 24, minus 5, and it's producing 72 minus 5, that is 67. Now this is 67 is my fourth term value. So here we got idea. We are going to proceed to the next type of a sequence. This is a geometric sequence. In geometric sequence, we study there is a common ratio between different numbers. For example, 2, 4, 8, 16, and 32. So we can see, so there is a common ratio, that is what the 2 in between these all numbers. Or you can say there is a one common multiple. If you're going to multiply to the one figure, and this is producing the next term value. So the first, we need to find the common ratio between these different numbers. And the second, we need to figure out this formula. So that's the nth term formula. That is equal to A1, and R is a common ratio into raised to power n minus 1. Here, A1 is your first term, it's your first term value. This is 2. So what about R is a common ratio, that's the 2. So here in this question, and n is a term value. You need to find any term value in this formula, and you will figure out the total figure of that term. For example, so we can see this is 2 is a first term value, A1 value, multiply, this is 2, that's a common ratio, raised to power, that's if you're going to substitute the n is equal to the 1 here, so 1 minus 1, this will produce 0. So any value whose power is 0, that's equal to the 1. So that means 2 multiplied 1 is equal to 2. So you can see this is our first term value. In the same way, if I'm going to substitute the value that is 2 into 2 raised to power, that's n value is equal to 2 minus 1. So this will produce 2 into 2 raised to power 1. So that is going to producing 2 multiplied 2 is equal to 4. So you can see this is my second term value. In the same way, if I'm going to replace this is n is equal to 3 here. So this, if there's an n term is equal to 3. So we are looking for 8 number. The answer is supposed to be 8 here. So that is the 3 minus 1. This is going to be 2. And 2 raised to the power 2. This is going to 4. And 4 multiplied 2 is equal to the 8. This is my third term value. In the same way, I can proceed to the fifth term value. So I'll find that's a number 32. So here we got this, the number. If I'm going to proceed to the any term value, let's suppose I'm going to proceed to the sixth term. So the 2 is my first, the arithmetic is my first, the number, that's the 2. This is first term value, and that multiplying to the 2, this is the common difference between. So that's a common ratio in between these different number, and raised to power 6 is my term value. If I want to figure out this is the term value, so that's going to produce 64. Now this 64 is the final, that's a 6th term value. So you can figure out any term value by using this nth term formula. I'm going to proceed to, that's another type of the questions here. For example, let's suppose if this type of a question, which of the sequence is equal to 64? So here we're going to use the same type of n-term formula. So to find out the 64 figure, for example, I'm going to substitute the same value, 64. This is what my term value is equal to. 2 is my first term value, into 2 is my common ratio between different number, raised to power n is my term number, I don't know, minus 1. So we don't know the term number, and we can figure out this term number in this way. For example, the first 2 is multiplying, other side is going to divide, and that will produce 64 divided by 2, that is 32. Now 32 is equal to the 2 raised to power n minus 1. So here you need to find out, so what is the base number of 32? So this is what 2 raised to power 5 is equal to 32 is equal to 2 into n raised to power 2 raised to power n minus 1. So here you can see they have a common base. So you can cut these common bases on the both sides of the equation. So in that way, 5 is equal to n minus 1. So powers on the left side will be equal to the powers on the right side. So that will produce 5 is equal to the n minus 1. Here, the 1 is minus, other side that will 8. So this will produce the 5 plus 1, that is 6. So here, we knew that the value of, that's a 64. This is a term value of the 6th term value. In the same way, if you substitute this 64 in a place of n, so here you will find the value. This answer will be 64. So here we got idea about the geometric sequence. We are going to proceed to the next, that is our cubic sequence. Now this cubic sequence is comparatively the complex. Why? Because there is first we need to find out the first common difference, and this is not a common. So that way we need to proceed to the second difference, and that's also not a common. And then we have to proceed to the third difference, and this third difference is a common difference. So that's why this formula will become complex here. So in this formula, we can see, for example, 6a is equal to the plus 6. This is what the second, this is going to be third common difference. So that's going to be, for example, if you're going to find out, so that's the figure. So in this way, the 6a is equal to the third difference. What about here we have a 12a plus 2b is equal to, that is my second difference. What about 7a plus 3b plus c is equal to my first difference. And in the same way, a plus b plus c plus d is equal to my first term value. So after figure out the a plus b plus c and plus d value, so we're gonna substitute this value in the given formula to get nth term value. For example, here we have a 6a is equal to 6, and 6 is multiplying, other side that's going to divide. We get the value of a is equal to 1. In the same way, so we're going to substitute this value in the given formula. So for example, an cube, so a value is equal to the 1. I'm going to substitute this value in given formula. So I got 1n cube. I'm going to take the second value, the 12a plus 2b is equal to the 12. So here I have a value of a. I'm going to substitute this value of a here. So that will produce 12 multiplied 1. That's the 12. So, and this 12 is plus, that's other side that will substitute it. That will subtract 12 minus 12. That's answer is 0. So in this way, overall, the b answer is equal to 0 here. So I'm going to substitute the b value in the given formula. So that will produce 0n squared. In the same way, I'm going to find for the c value. So that is the 7a plus 3b plus c is equal to 12. So in this way, 7 multiplied 1, this is going to be 7. And the b value, if I substitute, this is 0. This will become a 0 here. So this 7 is plus, other side that was subtracted. And answer is equal to, c is equal to plus 5. So here, the third value in the given formula, c is equal to plus 5. I'm going to substitute this value here. This will become 5n. In the same way, I'll proceed for value of the d here. That is the a plus b plus c plus d is equal to 13. I'm going to substitute this value of a, b, and c here. And you can see b value is a 0. This will become 0 here. And this is 5 plus 1. That will become 6. So here 6 is plus, other side that was subtracted. And this is going to produce 13 minus 6. So that's going to produce 7 here. So I got the value of the d is equal to 7. So in this way, here 1 into n raised to power 3, that's a 0 into n raised to power 2 plus 5. So where there's the figure 0, this will remove because the 0 is multiplying to the any number, that will cancel it. So our final formula will refine state that will produce n raised to power 3. This is n cubed plus 5n plus 7. We're going to find this formula. So how it is working. So first we're going to substitute the value of n is equal to the 1 here in this formula. So n is equal to the 1. So 1 cubed plus 5 multiply 1 plus 7. So that is 1 plus 5 plus 7. That is equal to what? 13. So in this way, this is my first term value. So that's equal to the 13. It means you found correct formula. In the same way, I'm going to substitute the value of n is equal to 2 here. So 2 cubed, that is 8. 5 multiplied 2, this is 10 plus 7. So that will sum of these all number, this is going to produce 25. So here, 25, you can see this is my second term value. I'm going to proceed to the third term value here. So if I'm going to figure out where, for example, if I'm going to substitute the value of third term, n is equal to the 3 here. So now this is the third term number. So n is equal to 3. So 3 raised to power 3, this is 27. And 5 multiplied 3, this is going to be 15 plus 7. So I'm expecting here 49 is supposed to be answer. So this my answer is 49. So this is my third term value. So in this way, you can figure out any term value by using the nth term formula of the sequence. So we got an idea about arithmetic sequence, quadratic, geometric, and a cubic sequence. So if you find any sequence in your exams, you have to follow that the particular method to figure out the nth term formula. And after getting the nth term formula, you can find any value in these sequence. So hopefully you got idea. If you didn't understand any point, so you can also write your doubt or your questions in a comment box. I'll try to answer your questions. So thank you very much for staying for a longer time and watch that video. Thank you very much.